Hello, future pilots. You are watching Pilot Preparation. My name is Rishi, and today we will be starting a very new topic called mass and balance, also famously known as payload. This topic is very important as pilot every day calculate the calculation which is there in this topic, and that is the reason this topic is very important as per say exam point of view as well, because this topic comes for 5% of the total air navigation. So it comes directly for 5 marks or sometimes 6 marks as well. So you can see the importance, isn't it? So this is very important chapter, and if you get this topic, which is very easy by the way, which I will help you out in, so you will be getting this topic and you will easily pass in air navigation with this confidence. Let's start with the very theory of this. So you can see an aircraft, passenger aircraft, Lufthansa, right? Looks very beautiful and very giant, isn't it? So do you know how much this aircraft weighs? This aircraft must weigh around 80 to 100 tons. That means like around 80,000 kgs to 100,000 kgs. That is too much of a weight. And this type of weight flies around for 2000 kilometer or 1000 kilometers. How is this possible, right? How can this be possible? Because even a bird cannot fly for that long, isn't it? And the bird weight is like 4 kg or 3 kg, I think. I don't know. I've never weighed any bird. I'm talking about some big birds. So you can imagine how much of a weight a plane holds, and it holds in air. So how much energy it must be requiring, isn't it? And not only energy, like when I'm talking about energy, I'm exactly talking about fuel it takes to fly from one place to another, because fuel is the energy which is getting burned here. By the way, the fuel is kerosene, which is used in aircraft. Do you know that? And why we use kerosene? Please put in the comment section why you think we use kerosene and not petrol. So we can say that fuel is very important, and a lot of fuel is required to fly an aeroplane. But at the same time, aviation industries are having marginal profit all throughout their year because of petroleum cost. It costs a lot, and they cannot consume it in excess, because then they will not be in profit, and many airlines are not in profit many times. Whereas if you want profit as well, and if you want all the passenger to get the cheaper flight, cheaper fare of the flight, you have to manage and get the mass and balance correct. So that is the reason we'll be calculating each and every kg which will be going inside the aircraft. And today we'll be doing all the calculation related to the mass of the aircraft. Here the mass and weight is the same thing. Actually, in physics we talk about mass and weight as a two different thing, but here we'll say mass is equals to weight, because that will not hurt our physics here. So let's start directly. That you can see this plane was standing here, and now the plane is flying like a bird, like a best bird possible, isn't it? So this is really fun. And let's start with the first type of weight we have to calculate in the aircraft. So basic empty mass or basic empty weight is the same thing, and it includes what? It includes airline's mass. Whatever is the mass of that model, that will be the first mass we need to calculate. And then we'll be calculating usable fluid. Usable fluid include what? Hydraulic oil. Hydraulic oil is used in rudder, ailerons, and different places, a lot of different places. So this is usable fluid, whereas we have unusable fluid. Unusable fluid is the fuel which cannot be used by the engine. The fuel which used by the engine. So we have this two type of fluid. So we can say this also we need to calculate under basic empty mass. Then we calculate lubricating oil which is required. You can imagine how much deep we are going. We are even calculating the lubricating oil which is going inside the engine. And then we have fire extinguisher, the weight of the fire extinguisher, because that also would be more than a kg. And then we have pyrotechnics. Then we have emergency oxygen. Emergency oxygen is again very, very important. If there is a hole in the aircraft or somewhere, the cabin pressure is not proper, then we can consume oxygen with the help of oxygen cylinder, which will be like coming, like oxygen mask, which will be coming. You must be knowing it with the help of air hostess already. They must be telling you all the time whenever you fly in the airplane. So we have this emergency oxygen, and then we have electronic equipment. Apart from the equipment which is there in the cockpit, we have electronic equipment, extra additional electronic equipment. So we have this also under basic empty mass. So summary, like we have already learned it very nicely, but again, let's summarize. So basic empty mass or tare weight, it is also known as tare weight, is the mass of the aircraft plus basic equipment plus unusable fuel plus oil. So yeah, in short, we can say like that, but it is pyrotechnic, emergency oxygen, electronic equipment, fire extinguisher, usable and unusable fuel. Okay, so a lot of things. So let's consider this as the first type of mass, that is basic empty mass. Now we'll add some more mass, which is very useful mass again. So here, can the aircraft operate in the above case? Can aircraft fly by itself after all this? No, it cannot fly by itself, isn't it? It needs you, the future pilots, or it needs the pilot which are traveling right now. So it needs pilot. Pilot can also be called as air crew, right? And even the air hostess can be called as air crew. So we can say it needs air crew plus their baggages. So we can say crew baggage. Why we are taking their baggage? Because their baggage also consists of a lot of weight. We want to calculate each and every one's weight. So whenever I'm saying air crew and crew baggage, in the end of the day, I'm calculating their weight. Okay, so I need to have them in my plane. Other than that, I also need some food and catering. So I also need some catering, isn't it? And I also need some bottled water. So packaged. Also, I need some lavatory chemicals if I want to go to toilet. So I need to have that as well to have a sanity, isn't it? So what all I need these things. But can you always say that a pilot mass or pilot weight will be always this for a particular aircraft? No, because the pilot change from one destination to other, the pilot changes. You might have seen that even with us, sometimes the pilot will also land and it will also get out of the plane and the new pilots will come, isn't it? So we can say this is not a constant load. It is not a constant weight. Even the crew will continuously change from destination to destination. So what I can say with this, that my air crew and the crew baggage is continuously changing, whereas even my packaged water is changing, my catering material is changing. Sometimes you will get noodles, which will be hyper costly, and then sometimes you'll get hyper costly biryani, which will not even taste good. So whatever is there, you can see that these are all variable things. This is not constant. So these type of load is also called as variable load because that changes from destination to destination. So we have now this total called as this basic empty mass plus variable load is called as aircraft prepared for service or dry operating mass. So this is called as this total like combination of basic empty mass plus variable load. Basic empty mass is the mass of the aircraft and fire extinguisher, pyrotechnic and that thing, plus variable load. Variable load is the air crew and their baggage and lavatory chemical. All these things are the variable load. So these two combined brings like this two combined is called as aircraft prepared for service, APS, aircraft prepared for service, or DOM, which is dry operating mass. They both are the same thing, dry operating mass. Why it is called dry operating mass? It is an operating mass. That means it can be called as operation mass. That means we can operate after this. Like now, aircraft can fly after this, but it is dry operating. That means it cannot be actually operated because it does not contain fuel. It does not contain fuel, and it also does not contain traffic. We'll talk about that later on. But for now, we can say it does not contain fuel. That is the reason it is called dry operating mass. So now I'm asking you one more question, which is very spiritual. So now aircraft is fit to go, but why it is made at the first place? Very good question, isn't it? So why it is made at the first place? Aircraft is made at the first place to carry passenger, isn't it? To carry passenger and to make them travel from one place to other, or to carry a cargo load. Just imagine tanks or warships, or maybe like something which is required to be delivered very fast. That type of cargo can be traveled with the help of planes because they are the fastest route of transport, isn't it? So what I can say, aircraft cannot travel without passengers, and this passenger is nothing but traffic. This is also called as this is, you can see, this looks like a congested place, so they are called traffic. And this is also called as traffic means anything which is going inside and increasing the load, so it is called traffic load because they also carry the weight. And it is also called as the famous word which is in the heading also, that is also called as payload. When I say payload, what I mean by payload, what I mean by that, I mean that these people are giving me money to fly them from one place to other. So what they are called as? They are called as payload. So even this cargo, anyone, the owner of that cargo is giving me the money to travel, to make it travel from one place to other. So I'm getting paid for that. So that is the reason my aircraft is operational at the first place, to make them reach from one place to other. So that is the reason they are called as payload, because they are the one who are paying for the aircraft to fly, isn't it? So the total mass of the passenger plus their baggage and freight means goods, including any non-revenue load, is also inside the payload. So passenger, baggage, freight means good, are payload, and it also includes non-revenue load. What is non-revenue load? Non-revenue load is on the top. You can see this part. This part is non-revenue. So what is this part, non-revenue load? Non-revenue load is the load which is carried by the passenger. So we are paying for our seats, right? We are paying for our load, but not actually. We are also paying for the baggages. But are we paying directly for our baggage? Until it is 14 kg, we are not directly paying for our baggage. So what we can say, until 14 kg, it is non-revenue load. That means it is not directly giving any revenue to the aircraft. It can be 7 kg, it can be 8 kg, it can be 10 kg. So the more kg you bring with you is the more loss the aircraft carry. Okay. So that is a non-revenue load here. So this is done. Now, one more thing is required to fly. What is remaining? Of course, the very important thing, which is the energy of the plane, that is, we'll say fuel on board. Very fancy word to say, right? So this is fuel on board. Just like baby on board, I have my fuel on board, isn't it? So this fuel on board consists of two things. This fuel on board consists of two things. First is BF, not your best friends. It consists of burn off of fuel. So BFF, best friends forever, or burn off fuel. It is also called as trip fuel. You can guess by the terms itself that what type of fuel it must be. It is the fuel which is consumed in the air. When the aircraft is flying from one place to other, the energy which gets consumed, or the fuel which gets consumed by the aircraft, is called trip fuel or burn off fuel, because that will be getting burned. Whereas we have alternate fuel. Alternate fuel is also called as reserve fuel. Now, this is the fuel which will be used in emergency condition. Just imagine that you cannot land at a particular station. So you have to again hold your plane in the air, or you have to land to some nearby station. So for that, you need some additional fuel that is called as reserve fuel. And sometimes the reserve fuel is also called to the fuel which cannot be consumed at all. Because of the tank shape, the petroleum tank shape, some fuel will always be kept. It cannot be used. So we can say that that is also a part of reserve fuel, which will be there in the aircraft, which will be increasing the weight, but it cannot be used. Now let's move to the useful load. So as I said, what is useful for an aircraft? Aircraft is very, like, aircraft loves passenger, aircraft love cargo, because that is very useful for them. That is getting them paid, isn't it? So useful load must be payload. Plus, useful load is something the aircraft also wishes for. That means more on amount of fuel or fuel on board, right? So we can say it is fuel on board. In this manner, you can remember this or by heart this, that useful load is nothing but payload plus fuel on board. All the load after operation phase, because it does not contains dry operation mass or APS, aircraft prepared for surface. So we are not taking this load. This load is not there. Only this load is there. Correct? So this is my useful load. Now let's come to zero fuel mass. So any type of mass or the total mass of the aircraft without fuel on board. So that is zero fuel mass. So total mass of aircraft minus fuel on board. So when there is no fuel in the aircraft, it can be called as zero fuel mass, isn't it? So now this is done. What is maximum zero fuel mass? So maximum permissible mass of the aeroplane with no fuel on board, right? With no fuel on board. Again, the same thing. These are like interchangeable things. You will see a lot of terms in this chapter, but all the terms can be like, can be joined together and can be called as one. Just like ZFM and MZFM, this is ZFM. So this ZFM and MZFM are kind of interchangeably good. Okay, so we can say this maximum permissible mass of the airplane with no fuel on board. Okay, so this is maximum zero fuel mass. Now, what is operating mass? As I talked about, the mass which is required to operate a plane, without which the plane cannot operate. So can we say that without payload, the aircraft can operate without passenger, isn't it? It can fly without passenger, isn't it? So we cannot say that this is very important operational mass. So this is not operational mass. So what is operational mass? Fuel on board is my operational mass. Plus I also need basic empty mass, and I also need variable load. I also need my pilot, isn't it? I also need my crew with me. So I can say I need basic empty mass plus variable load. So what I can say, this is nothing but FOB plus dry operating mass. This is nothing but dry operating mass, isn't it? So I got these two. Now let's come to the next part, which is ramp fuel or block fuel. We have learned about fuel on board. Fuel on board consists of trip fuel and reserve fuel. But that is the fuel when you are taking off. Those two types of fuel are there in your aircraft. But before taking off, if you go back, then you were taxiing. And before taxiing, you start off your plane. When you're starting off your plane and when you're taxiing, these two also require some fuel. So that is nothing but rank fuel and block fuel. So that is nothing but total fuel on board plus taxi fuel, plus it also has fuel on board plus taxi fuel, and it also has startup fuel. So we can say RAM fuel is nothing but fuel on board, taxi fuel, and startup fuel. Remember, note down in your book that trip fuel does not contain taxi or startup fuel. Why trip fuel does not contain taxi or startup fuel? Of course, for the obvious reason that taxi is done on ground, startup fuel is consumed on ground, and trip fuel is the trip ka fuel, isn't it? So when you're traveling in a journey, you're having a trip in air, the fuel which is consumed in air will be called as trip fuel. So that will not even consider reserve fuel, isn't it? That will not have reserve fuel. Why it will not have reserve fuel? Because reserve fuel is reserve. It is not getting consumed in the trip. So that is also not the part of trip fuel. Now let's come to contingency fuel. Contingency fuel, the fuel which is required to compensate winds. The fuel which is required to compensate winds is called contingency fuel, because you don't want to get fly away with the wind. You want to fight that wind, and you can only fight that wind when you have a lot of weight. Otherwise, you will just fly away like a paper, isn't it? So sometimes you need reserve fuel. You need reserve fuel, not trip fuel. Why I'm saying reserve fuel? Because again, this type of fuel should not be getting consumed. So this will not come under trip fuel. It will come under reserve fuel. Okay. So this is also done. Now, let's revise till here, isn't it? So first we talked about basic empty mass. Basic empty mass consists of airplanes manufactured mass plus pyrotechnic plus fire extinguisher plus plus what we say oxygen mask and usable fuel, non-usable fluid, and lubricating oil. And I'm missing some 1-2 things you can remember. Basic empty mass plus then we had this variable load. That gives us variable load is nothing but pilot and their baggages, aerosters baggage and cabin crew and baggage and lavatory chemical and bottled water I said. And then we have this thing also, catering material, isn't it? So that is variable load. This gives me APS, aircraft prepared for service, or DOM, dry operating mass. Then I learned about this also, but then I learned that I need fuel on board. So fuel on board contains what we say trip fuel, and it also contains reserve fuel. And also I learned that I need what? I need what? Other than this, do I need something? I have this dry operating mass. I have this fuel on board. I need very important thing, which is payload. It is also known as traffic load. So this is all I have learned. Then we also learned about contingency fuel, MZFM, maximum zero fuel mass, the mass of the airplane without fuel. And we learned about contingency fuel, the fuel which is reserved in the wings to compensate winds. So that is there, and a lot of small things also we learned. Now let's directly go to the next part of the chapter, which is takeoff weight or maximum takeoff mass. As I said, mass and weight are the same thing here, so we will use them interchangeably. So maximum permissible total aeroplane mass at the start of the takeoff run. So when you're taking off, whatever mass the airplane is carrying is called as maximum takeoff weight or maximum takeoff mass. So this looks like a brick. You're flying a brick, so that is the reason I brought this thing. So what we can say, so whenever you are given a question, you have to always find out what? You have to always find out maximum takeoff weight, always. So either it will be directly given, either it will be given in form of MLW and MZFW also. Like this will be given directly also, and with MLW and MZFW. Now, what is what is MLW and MZFW? I told you MZFW is nothing but maximum zero fuel mass. And what is MLW? This is nothing but maximum landing weight. Now, if I want to convert maximum landing weight into MTOW, this is takeoff weight. So if I want to convert everyone into takeoff weight, what I need to do? I need to convert this to in takeoff weight. So what I can say, this is my maximum landing weight. When you're landing, what will happen? When you're landing, what will be consumed? When you're landing, what will be consumed by the aircraft? Will the passenger get consumed? No. Will the airplane's mass will decrease, or will the airplane's design will decrease or will lose some weight? No. What will be lost? The fuel will be lost. And what type of fuel will be lost? Trip fuel will be lost, because that is the fuel which will be lost in throughout the trip, right? So what I can say, if I add trip fuel in the maximum landing weight, what will happen? I will get MTOW, that is nothing but maximum takeoff weight. This will be 1, this will be 2. Okay, I will get one more value of maximum takeoff weight, because maximum landing weight plus trip fuel should be equal to maximum in the start of the weight, whatever I had during the takeoff, I should have the same weight, correct? Similarly, MZFW is maximum zero fuel weight, zero fuel weight. So if I had fuel on board means what? Trip fuel plus reserve fuel. If I add these two, what I will get? I will get maximum takeoff weight again, and this will be my third type of maximum takeoff weight. So I got three types of maximum takeoff weight. Now I have that variety which I want in my life. So I have my first maximum takeoff weight, which is directly given that during takeoff what weight you have, and second is maximum landing weight plus trip fuel. So that again gives me maximum takeoff weight, and this is maximum zero fuel weight, which needs to be added with fuel on board, which gives me maximum takeoff weight part 3. Now that I have the variety, I will write first the formula and then I will tell you why I needed the variety. Okay, so maximum takeoff weight formula is dry operating mass or APS plus FOB, which is fuel on board, plus payload. So this gives me maximum takeoff weight. Maximum takeoff weight is nothing but dry operating mass plus fuel on board plus payload. You can imagine what all we studied. We combined all the things and we got maximum takeoff weight, because we need fuel for taking off. We need payload for taking off. We also need the dry operating mass or aircraft prepared for service, which include variable load and which also include basic empty mass. It includes basic empty mass and variable load, isn't it? So I got all the things and this is giving me maximum takeoff weight. So this formula is very, 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 very important, and you can never forget this until you die. Okay, so what I have taught you right now, this is maximum takeoff weight, which is equal to DOM plus FOV plus payload. FOB plus DOM plus payload, DOM plus FOB plus payload. You can remember this like this, FOB plus DOM plus payload. Okay, now after this, we have to use maximum takeoff weight, either this one or either this one or either this one, isn't it? So we cannot use like all three, and they all three are not same. Remember, all three are not same because these are theoretical values, and these theoretical values will vary a bit by bit. Okay, so we cannot say that they are exactly same. So we can say the first rule is rule 1: to calculate maximum payload, we take the lowest of the three. Lowest of the three means this is MTOW1, 2, MTOW2, and MTOW3. So we take lowest of the three, like first, second, third. Which one of them is lowest? We'll take them, we'll put that value here, lowest of the three, and we'll find out payload. Got it? To calculate payload, what we need to do? We need to put the maximum takeoff weight value, the lowest of the three, and then we can get the payload value. And that payload value will be the highest payload value. So we say to calculate the maximum minimum payload, we take the lowest of the three. Maximum minimum payload means I want more amount of passenger to come. I need more amount of payload in my aircraft, but also I need to keep my aircraft safe. So I need to have a maximum minimum load of the aircraft. So what I do is I'll take the less value, or MTW, I take the smallest MTW value, and then I subtract that with the DOM and FOB, and whatever value I get is the highest amount of passenger or highest amount of cargo I can hold in the airplane. Got it? So if you want to see how it will look like payload is equals to MTOW lowest minus FOB minus DOM. It will look like this, isn't it? Now let's move on to the rule 2. What does rule 2 say? To calculate maximum fuel that can be carried on board, we take the lowest of the first two. So whenever we need to find the fuel or the fuel on board, FOB, when we are saying fuel, whenever we need to find fuel on board, we take the lowest of the two. Lowest of the two means MTOW1 and MTOW2, whichever is the lowest, 1 or 2, whichever is lowest, we take that value. We don't consider MZFW in that case. Why we don't consider MZFW in that case? We can see here in this way that we know that MTOW is nothing but MZFW plus FOB. That is nothing but DOM plus FOB plus payload. DOM plus FOB plus payload. And you need to find out what? You need to find FOB. But can you find out FOB if you are using MTOW3? If you are using MTOW3, that is nothing but MZFW plus FOB, isn't it? So FOB will get cancelled because they will be the same value. So whenever you need to find FOB, you use MTOW1 or MTOW2. So you take either of the two value. So you take either MTOW1 or MTOW2. So you take the lowest of these two values and find out the fuel on board. Hello, I hope you're enjoying today's class. If you do, please like, share and subscribe so that you won't miss other videos which will be coming very soon. Apart from this, you can join me for one-on-one classes. So for that, you can ping me on WhatsApp or on call. You can directly call me or mail me, and then we can have a demo session, and then in the demo session I'll tell you all the structure, and then we can have a further classes. Other than this, you can have classes for air navigation, regulation, technical general and whatnot. So please try to think of this one, and because our classes are very affordable and it is better, I bet you that it is better than anyone else. So try it and then tell. So bye. Okay, so we have learned very nicely rule 1 and rule 2, but I am very sure that you may get confused with this amount of material. So let's just revise it again. So we learned the formula, which is MTOW, that is maximum takeoff weight, is equals to APS, also known as dry operating mass, plus FOB, that is fuel on board, plus payload, that is our traffic load. Okay, so these things are there. And we also learned that APS, or dry operating mass, and fuel on board gives us operating weight. Dry operating mass, remember, operating. So dry operating mass and fuel on board, it also has O, so it will come in O, operating weight. Whereas useful load is again fuel on board and payload. So useful load is again fuel on board and payload, so that is useful load. So because we need money, so this is very useful. So in this format, you can remember this. Apart from this, we learned that we get 3 MTOW value. One is direct value, MTOW value, which is the maximum takeoff weight value. And we get the second MTOW by MLW, maximum landing weight, plus trip fuel. And then we get the third value of MTOW by maximum zero fuel weight with fuel on board. When we add zero fuel weight with fuel on board, we get the third value of MTOW. So this is how we get the 3 MTOW values. And what is the rule 1? Rule 1 says, if you want to find out payload, you need to find out the lowest of the 3 MTOW value. And if you want to find out fuel on board, then you take lowest of the 2 MTOW value in your formula and put and get the answers. Now let's see the other terms like structural limitations, because again, this is not very new thing, but very important at the same time, to understand the theory. So these are the limits up to which aircraft can be loaded. Any load beyond this will be endangering the structure, and hence it is not acceptable. So any structure in this world can hold a certain amount of load, just like a rectangular structure, spherical structure, hold different amount of load, though they are made of same material. Similarly, aircraft made up of some things have a structure, and the structure can only hold a certain amount of load. So we have to always put the load less than that structural load, isn't it? So we have this terms as MSLM. MSLM is nothing but MLM, maximum structural landing mass. We can ignore that structural landing mass and we can directly write in our formula, we can directly write this is nothing but MLM. Then if we add trip fuel, I will get MTOW2, isn't it? And we have MSTOM. MSTOM should be what? Maximum structural takeoff mass, isn't it? Similarly, we have MSTM. MSTM is nothing but maximum structural taxi mass, which we don't care because this is not very much useful, but it was there in your theory, so I thought to tell you. Then we have maximum zero fuel mass. Zero fuel mass is what? Zero fuel mass is, again, you already know since your childhood now that maximum zero fuel mass is the mass without fuel on board. So if I add fuel on board, I will get MTOW3. Now with this, the theory is not yet done because we have performance limitations as well. So performance limitation, like, you know, your performance in the games vary from time to time and from place to place, right? So if you are playing football in water or in rain, everyone's performance will be less, though the fun will be more, but performance will be not good because you will not be having the grip. Similarly, if a badminton player is playing on a cement court or a wooden court, the performance vary according to the court. So similarly, performance of the aircraft also vary, and let's see that. Such as performance limitations such as runway available for takeoff. So which runway, how that runway is, it also affects, and landing runway is also very important. Then we have weather conditions such as high temperature, pressure, winds, precipitation. High amount of rain is called precipitation or like something like that. So we have high amount of wind that can affect the performance of the aircraft. That will, if the performance of the aircraft is affected, high amount of fuel is required to land the aircraft or to drive the aircraft. So if the high amount of fuel is required, somewhere we have to decrease the load, isn't it? To have the maximum takeoff weight, isn't it? So what we'll do in this kind of case, will reduce the load. So rate of climb and altitude requirement for obstacle clearance. So if you are traveling from New York and if you have a lot of skyscrapers, or if you're traveling near Mount Fuji and Mount Everest, so you will know that these things are obstacle and you need to carry a lot of heights right away. So that type of right away height will also take a lot of fuel. So again, that will affect the performance of the plane because you are driving the plane to the extremes. And then engine out, like engine performance is also need to be checked. So performance requirements have effect on limiting the weight. So we have to limit the weight. So that is the reason it is said, like, now you know, you don't need to fear with the term performance limited landing mass. That is like performance limited landing mass is nothing but MLM, maximum landing mass. Performance limited takeoff mass is nothing but TOM, that is nothing but takeoff mass or takeoff weight. So we can say this is MTOM1, right? This is nothing but plus trip fuel will give me MTOM or MTOW2. Then this is RLM. RLM is nothing but restricted landing mass, or MLM again. And RTOM is nothing but restricted takeoff mass. So you don't need to fear by these terms. That is the reason I'm teaching you right now, so that you don't need to fear the questions. So now we are kind of ready, set, go for the questions. Let's go for the questions. So let's see the first question. The traffic load. So the question is saying the traffic load includes what? So it includes passenger mass, baggage mass, but exclude any non-revenue load. Includes passenger mass, baggage mass, and cargo mass, but exclude any non-revenue load. Include passenger mass, baggage mass, cargo mass, and any non-revenue load, or include passenger mass, baggage mass, and any non-revenue load, but exclude cargo. So these are 4 options. You can pause and write your answer in the comments, or I will directly say the answer. So the answer should be the traffic load is something which is giving me, this is nothing but payload. And payload include passenger mass, baggage mass, plus cargo, plus freight, and non-revenue load as well. So it is not excluding any non-revenue load. It is not excluding cargo. It is not excluding non-revenue load. So here, this will be the answer, option C. So this includes everything. Payload includes everything. Let's go to the second question now. The dry operating mass of the airplane is. This is very good question. This is not very easy or very right away question. So dry operating mass is what? Dry operating mass, or we can say the formula, that is nothing but maximum takeoff weight is equals to dry operating mass plus FOB plus payload. Correct? So what I know, I don't need to even see these things. I directly don't see these things. I know where they will play with me. So I don't let them play with me because I don't like playing in my exams, isn't it? So this is my maximum takeoff weight and this is my dry operating mass. So what I will do, this is FOB and payload. What would be FOB plus payload? That would be nothing but FOB plus payload will be useful load. Correct. So I will say DOM is nothing but MTW minus useful load. So let's see if there is something like that. So we have dry operating mass of an aircraft is takeoff mass minus operating mass. Operating mass is DOM plus FOB, so this is wrong. Then we have landing mass plus trip fuel. So landing mass plus trip fuel is nothing but MTW 2. This is not our answer. Again, useful load minus operating mass, that doesn't make sense. Takeoff mass minus useful load. So this is the answer. So this option D will be my correct answer. Correct? Like that, I have completed 2 questions. Am I going in a bullet speed? Yes, I am. So let's go to the third question. Very excited to see the third question. And it is not looking very easy, but it is easy. Don't worry. So the third question is MSTOM, MSLM, PLLM, ZFM, MZFM. Okay. So you can see a lot of fancy words are given, but as I told you, don't fear the fancy because after fancy, there's a win. So as we can say, this is my first block, which is MSTOM. That is nothing but my MTOM, as I said. So this will be my MTOW1. That is equal to 42100, isn't it? Now, what is my second one? Second one is MSLM and PLLM. As I said, MSLM and PLLM is nothing but maximum structural landing mass and performance limited landing mass. They both are the same value. And in the end of the day, whatever I need to find out, I need to find out MTW1, MTW2, MTW3, and I will take the lowest of the 3. So I will take the lowest of either of these two. So I directly put the lowest of these two value, or for you guys, I will put both the values for now, but you have to understand that you can directly put the lowest of the value. That means you don't need to write this value at all, because this is MSLM, which is 35,000 and this is 33,000. So which will give me the lower value? 33,000 will give me the lower value. So I should put directly here the lower value. But for now, for you guys, I will put both. So this is my MSLM, which is landing mass, maximum structural landing mass, and this is performance limited landing mass. Then I have MZFM, maximum zero fuel mass. What I know in landing mass, what I add trip fuel. So I will first hunt for trip fuel, whether it is given directly or not. So maximum trip fuel is already given to me. It is here, right? So trip fuel is like plus trip fuel, and this will be plus FOB, isn't it? To give me MTOW2, these two will give me MTOW2 and this will give me MTOW3. So this will be MTOW2, MTOW2, and this will be MTOW3, isn't it? So MSLM is how much? MSLM is 35,000 and my trip fuel is 9,000. So 35,000 plus 9,000 is 44,000, isn't it? 35,000 plus 9,000 is nothing but 44,000 kg. And then this PLLM is nothing but 33,000 plus 9,000. So this will be 32 or 42,000 kg, isn't it? So this is this. Then we have the third value, which is MZFM. MZFM is this. This is 31,000 plus 9,000. Not plus 9,000. We have to add full value, which is FOB value. So for FOB, we have to first find out FOB. FOB is nothing but trip fuel plus reserve fuel. So that is nothing but 9,000. plus 9,000 plus contingency fuel, which is 1,000, plus alternate fuel, which is 500, plus final reserve fuel, which is 400. Have I left something here? I have left total fuel capacity. But is this a good value to add? Total fuel capacity means my capacity of the fuel of the aircraft. Do I fill the fuel capacity, the tank of the fuel capacity fully in the aircraft? I don't fill the fuel tank fully ever because I don't require that amount of fuel. Just imagine if I'm going from Delhi to Pune or if I'm going from Nagpur to Pune, that is a very short trip. I don't need to fill the tank as much as Delhi to Kanyakumari, right? That is a very long trip. So according to the trip distance, we carry that much amount of fuel only. So total fuel capacity is the capacity of the aircraft, and that is too high. We don't need to worry about this total fuel capacity. This is a distracting number. This is given to fool you guys. So total fuel capacity is never used because that type of fuel is never used in the fuel tanks. What is used is trip fuel and reserve fuel. That is never equal to the total fuel capacity. That is the highest amount of fuel one can carry, isn't it? So we have this total value as 9,000 plus 1,000 plus this. So this will be 10,900 kg, isn't it? So I need to add 10,900 kg to my MZFM. What is my MZFM? This is 31,000, and 31,000 plus 1,000, 10,900 is nothing but 41,900. So I got all the value. This is my MTOW1, this is my MTOW2, this is my MTOW3. You can see how I could have easily ignored the first MSLM value here itself, because again, this was bigger than PLLM value. So I don't need to even calculate MSLM value. So directly I got PSLM value, which is MTOW2, and this is 42,000, this is 42,100, this is 41,900. Which one is the lowest? I got this as my lowest value. So I should be using this if the question is asking me traffic load. So it is asking me traffic load. So I was very correct and I already got the answer. Can you see that? I already got the answer. That is option C, which is saying what is the maximum takeoff mass. Takeoff mass is this only, na? This is maximum takeoff mass is maximum takeoff weight, and it should be the lowest of the three value. So I already got this 41,900 kg value, which is correct. But I need to also calculate for you guys what is traffic load. So traffic load is equals to maximum takeoff weight minus FOB minus DOM. So we have this maximum takeoff weight minus FOB minus DOM. So maximum takeoff weight is what? That is 41900 minus FOB is how much? FOB is 10900 minus DOM is how much? That is equal to, DOM is how much? This one. DOM is 19,000. So minus 19,000. So that should be equal to 419,900 minus 10900 minus 19,000. So this is equal to 12,000 kg, which is my answer here. So answer is option C. Okay, now let's go to the question number 4. Again, I'm very excited for the question number 4 because it looks very fancy again. MZFM is given as 47,000 kg, MTOM is given as this, and MLM is given. So what I will first do, I will first write these things as MTOM, MLM, and MZFM. Correct? I will first, like right away, I will make this table and then I will add plus trip fuel plus FOB will give me MTOM1. This is MTOM2. This is MTOM3. Correct? Or a maximum takeoff weight 1, maximum takeoff weight 2, and 3. If I add trip fuel, isn't it? And if I add FOB, I will get MTOW3. So this is first thing which I always do whenever I see this type of question. Then what I will do next is, let us assume that there are no performance limits, so that the regulated takeoff mass and landing masses are equal to the structural takeoff mass and structural landing mass respectively. So whatever theory, fancy theory they have given, I don't give a damn to that. Why? Because that is not at all like that is not at all required for my question solving. So I can directly cut that and I will very nicely, very beautifully ignore that part. Then let us also assume, that dry operating mass is 34,000 kg. I will assume it because anyway, I cannot assume by myself. Only the questionnaire can assume it. So that is 34,000 kg. And the actual traffic load is 12,400 kg. So the actual traffic load is 12,400 kg. That means I am given my payload. So in this case, the payload is already given. So maybe this time I don't need to find the payload. Let's see if I need to. The takeoff fuel load is 16,000 kg. Takeoff fuel load must be what? Fuel on board. When you're taking off, whatever fuel is on board is called takeoff fuel load. Okay. So takeoff fuel load is 16,000 kg and 8,000 kg of fuel was used in the flight. 8,000 fuel got burned off. Was used in the flight means during the trip. So I can say this is my trip fuel and this is my FOB, correct? So can extra load be carried? If yes, how much? They are saying that can extra traffic load be carried because any other load is not carried, right? Other than traffic load. So can extra traffic load be carried? If yes, how much? But why they are asking me traffic load when they have already given the traffic load, isn't it? If they have already given the traffic load, how can I again find out the traffic load? We can actually find out the traffic load. Why? Because they are talking about maximum traffic load. Whenever we try to calculate with the help of formula, we find the maximum traffic load. And this is what? This is actual traffic load. That means this is the load which will be going inside the aircraft, but we can have little more load, right? Sometimes in some cases when we calculate and we find that okay, maximum traffic load comes out to be, just imagine, 900. Okay, and my traffic load was actual traffic load is 700. So I have 200 kg more to fill in my aircraft, correct? So similarly, if my actual traffic load and maximum traffic load is same, then I cannot have any extra load in my aircraft. Otherwise, it will damage my structure. It will damage the performance of the aircraft. So what I will do, I will say underloading is when maximum traffic load minus actual traffic load is equal to some value, isn't it? So I need to find out this value, and this value will be my answer to yes or no. And if there is some value, then I will say yes, we can carry little more load, correct? In this case, if there is some value, if this comes out to be 0, then I will say no, we cannot carry any more load, correct? So let's do all the. So let's solve the question. So first is maximum takeoff mass, that is given as 62,800. So this will be 62,800. Then I have maximum landing mass. Maximum landing mass comes out to be 54,900. And I have trip fuel as 8,000. So it will be 8,000. So this will be 62,900. Now the third is MZFM plus FOB. MZFM is 47,000. And I have FOB as 16,000. So this comes out to be 6 plus 7. This is this, and this is 63,000. So I'm getting 62,800, 62,900, and 63,000. So the winner is 62,800, correct? So this is my lowest value. So I will use this for my payload formula. So what I know is MTOW is equals to FOB plus payload plus DOM, correct? So my payload or maximum payload is equals to MTOW. MTOW will be 62,800 minus FOB. FOB is how much? Fuel on board is 16,000. 16,000 minus DOM is how much? 34,000. So this comes out to be 62,800 minus 16,000. 62,800 minus 16,000 minus 34,000. This is 12,800 kg. So this is 12,800 kg, but my actual takeoff load is 12,400 kg. So I am putting 400 kg less in my aircraft. So what will be my answer? My extra load will be how much? Extra load will be 12,800 minus 12,400. So that is 4,400 kg. Okay, this is the extra load which I can carry in my aircraft. As this was again a very good question. Now let's move to the fifth question, which is aircraft weight without fuel and payload is 90 ton. This is T means ton. And aircraft prepared for this is nothing but aircraft prepared for surface weight. So whenever they are writing aircraft weight without fuel and payload, without fuel and payload is what? Without fuel and payload is dry operating mass. Just imagine total mass minus payload minus fuel on board will be giving me what? It will give me dry operating mass. That is nothing but aircraft prepared for service mass. So this is what, so we, whenever they write a fancy word like this, aircraft weight without fuel and payload, they mean DOM or APS, aircraft prepared for service. It was given in the bracket as well, but many times it will not be given in the bracket as a hint. So you have to always remember that this is equal to APS or DOM. So now what next is given? RTOW is given, restricted takeoff weight is given, restricted landing weight is given, and maximum zero fuel weight is given. So I am given with everything. So again, I will say this is MTOW is given, MLM is given, and maximum zero fuel weight MZFW is given. So I will write a restricted takeoff weight as 167 ton. Okay, this is 167 ton. And my maximum landing weight is how much? This will be plus trip fuel. This will be plus FOB always. This will be second value. This will be third value. This is first value. So first, let's find out whether we are given with trip fuel directly and FOB directly. Sometimes we have to find out FOB and trip fuel as well. So let's see if that is the case or not. So I am given with reserve fuel, flight timing, and diversion timing. Fuel flow throughout is 2.5 ton per hour. This doesn't sound like a very straightforward question, isn't it? It has timings, isn't it? So it is not a very straightforward question, though it is not very tough question again. So we are given fuel flow throughout is 2.5 ton per hour. That means every hour, how much fuel is getting consumed in the trip? It is 2.5 ton. In these type of question, first we need to find out trip fuel and fuel on board. After that, we need to continue the question. So first we'll find out trip fuel and fuel on board. So fuel on board has a trip fuel plus reserve fuel, right? So reserve fuel is already given, that is 3 ton. And also reserve fuel will also have some other element, which is diversion fuel. Diversion fuel is the fuel which is used when the aircraft is getting diverted from the landing station. So diversion fuel is equal to diversion time multiplied by fuel flow rate. Why fuel flow rate? Because diversion time is in hours and fuel flow rate is in tons per hour. So hour multiplied by tons per hour will give me how much? Will give me the weight or the diversion fuel weight. So that will be nothing but 0 hour 51 minute multiplied by 2.5 ton per hour. Correct? So I will say 0 hour 51 minute 00 second multiplied by 2.5. So that this will give me 2 hours 7 minutes. That is not the weight, right? So this will give me 2.125 ton of reserve fuel, extra reserve fuel. And then I have flight time. This flight time will give me what? This will give me trip fuel, because that particular duration is the duration when my fuel got burned or my trip was on. So that trip fuel will come from the flight time. So flight time is 3 hour 33 minute multiplied by 2.5 ton per hour. So this will give me 3 hour 33 minute multiplied by 2.5 ton. So this will give me 8.875 ton. So now I have my trip fuel and my FOB also. So my total FOB will be how much? FOB will be RF plus DF plus TF. That is equal to 8.875 plus 2.125 plus 3. So that is equal to 14 ton. Now I need to find out the maximum possible takeoff weight and payload, right? So now I can find out my takeoff weight and payload. So takeoff weight will be the lowest of the three. So this will be MLM plus TF. This takeoff trip fuel will be how much? 8.875. So my MLM is nothing but RLW, restricted landing weight. That is 139.55. 139.55 plus trip fuel is how much? 8.875 plus 8.875. So that is equal to 148.425 ton, right? This is 167 ton. This is 148.425 ton. And MZFW should be how much? MZFW is 132 plus FOB, which is 14 ton. So this is 146 ton. So this is the lowest of the value. So what I can say, my maximum permissible takeoff weight is equals to 146 ton. Now I've got maximum permissible takeoff weight. What will be my payload? Payload is equals to MPTOW minus FOB minus DOM, correct? So this is nothing but 146 minus FOB. FOB is how much? Fuel on board is 14 minus DOM is how much? DOM is 90 ton. So I have my 146 minus 90 minus 14. This is 42 ton is my payload. This is my answer. So we don't have time to even celebrate right now because there's a lot of questions to do. The next question is saying load sheet reads aircraft weight, no fuel, no payload. Again, no fuel, no payload means this is my dry operating weight. This is my dry operating mass or dry operating weight. This is 63,200 kg. Then maximum takeoff weight is this route fuel excluding reserve. Route fuel means what? Trip fuel again. Route fuel is nothing but trip fuel. So this is trip fuel and reserve fuel is unused fuel. So this is 3,000 kg. If the maximum landing weight is 76,500 kg and MZFW is also given, so directly just write the table first. So what I know, I have my MTOM, I have my MLM, I have my MZFM, right? I have my MTOM as, and this will be trip fuel, this will be FOB, correct? So this is my first value, this is my second, this is my third value. I will just use every time this type of setup because this is very easy and very useful as well. So my maximum takeoff weight is 99,000 kg. Then my route fuel is, trip fuel is given as 18,200. I have to add it in maximum landing weight. This is 76,500. So 76,500 plus 18,200. So this will give me route fuel. And then this third one is reserve fuel. So reserve fuel will be added to the trip fuel to form fuel on board. So it will be 74,000 plus 3,000 plus 18,000. So 18,000 plus 3,000 is 21,200. 21,200. So that is nothing but 200 plus 5, 7, 8, 9. 7, 8, and 9. So this is this. And this is how much? 7, 0, 0, 8, 6, 12, 13, 14, 7, 8, 9. So I have these three values as 99, 94, 95. So the lowest value of the three is 94,700 is my chosen value. So my takeoff weight when maximum payload is carried. So when maximum payload is carried, my takeoff weight should be 94,700. So again for payload, what I can say? MTOW minus MTOW2 minus FOB minus DOM. Correct? So that will be equal to 94,700. 94,700 minus FOB. FOB is fuel on board is how much? FOB is fuel on board is how much? 21,200 minus 21,200 minus DOM is how much? DOM is 63,200. 63,200. So this comes out to be 10,300 kg. So I'm done with the sixth question, and that was very easy one again. Let's move on to the question number 7. The empty mass of an aeroplane is given as 44,800 kg. Operational item includes crew standard mass 1060 kg or 2300 kg. If the maximum zero fuel mass is 65,500 kg, the maximum traffic load could be carried is how much? So the empty mass of the airplane is given. So basic empty mass is given as 44,800 kg. If I add variable load in that, variable load is crew standard mass, that operational item and crew standard mass is given. So I can say variable load is how much? That is given as, which is including crew, right? So I can write this is my variable load. So this is 23,000 kg. So this will be basic empty mass. This total is my dry operating mass. Correct? This total is my dry operating mass. So I can say 44,800 plus 23,300 is equals to, so dry operating mass is 47,100 kg. Now, if the maximum zero fuel mass is given, MZFW is given as 65,500 kg. The maximum traffic load will be how much? For traffic load, what is the formula? That is MTOW is equals to FOB plus DOM plus payload. I need to find out payload, correct? But I don't have FOB here. Have I been given FOB anywhere? I'm not given FOB, but I don't need to worry about FOB because I'm not even given MTOW, no? I'm given MZFW. MZFW is what? MZFW is nothing but MZFW. No, I'm sorry. But I'm given MZFW. So MZFW is very useful here because MZFW is nothing but MZFW plus FOB is equal to MTW. But FOB gets cancelled here. So I can say MZFW is equals to DOM plus payload. Correct? DOM plus payload. So what I can say, my payload is equals to MZFW minus dry operating mass. So my MZFW is how much? That is 65,500. So 65,500 minus payload. Payload is minus dry operating mass, that is 47,100. So 47,100. So that is equal to 18,400 kg is my payload. So this will be answer C. Option C is my answer. So I am done with the question number 7 as well. We are going in a bullet speed, you know. Now let us see question number 8. I am very excited right now. So determine the landing mass. It seems like it will be a little tougher from now on, but it is not tough because you are with me, and trust me, everything is so easy in this chapter. And this payload chapter consists of 5% of your full air navigation. So this is very, very important topic. So determine the landing mass of the following single engine aeroplane. So standard empty mass is nothing but basic empty mass. Operational equipment is nothing but again variable load. And then we have pilot plus front seat passenger. Again, front seat passenger is payload, and this is what? This is variable load. This is variable load. This is payload. So this is a mixture of two, right? This looks like a very interesting question. Let's see what happens. So this is my variable load ka part, and this is my payload ka part. So, and this is cargo mass. Cargo mass is what? Cargo mass is again payload. and ram fuel is block fuel. That is 60 gallon, and trip fuel is 35 gallon. It should be in LB, right? Because everything is in LB, so this should also be in LB. LB means pound, I guess. So fuel density is 6 pound per gallon or 6 LB per gallon, right? So what I can say with this is I first need to convert my block fuel and trip fuel in gallon, or sorry, in LB, correct? So first and foremost, I need to convert my ram fuel and trip fuel in LV. First of all, we also need to remember that ram fuel is equal to FOB plus taxi fuel plus startup fuel. But when you're not given taxi fuel in the question, you cannot subtract that taxi fuel. So we will assume that taxi fuel is negligible and startup fuel is negligible. So we will directly use ram fuel as my fuel on board. Okay. So my fuel on board is equals to 60 gallon multiplied by 6. So 6 LB per gallon. So this is nothing but 6 is 36, 360 LB. And my trip fuel is nothing but 35 multiplied by 6. 35 into 6, 210 LB. Right? So my reserve fuel is equals to 360 minus 210 LB. So this is 150 LB. Correct? This is my reserve fuel. I have calculated whatever I could with the help of fuel. Now what is next? I need to find out takeoff mass or takeoff weight, or what I need to find out? Payload. I need to find out, determine the landing mass of the following single engine aeroplane. That means I need to find out MLW. Do MLW have what? Like, what does MLW contain? MLW contains everything. MTOW minus trip fuel is nothing but MLW. Correct? So what I can say, I can add everything in the world except trip fuel. So that is the reason I use this reserve fuel. I made this reserve fuel. That is nothing but FOB minus trip fuel will be my reserve fuel. So I can use this instead of this, because FOB contains trip fuel and trip fuel I cannot add. So I will use reserve fuel. So what will be my MLW? MLW is equals to, first is my MLW is equals to payload plus dry operating mass plus reserve fuel. Now let me tell you how I write the payload. So first payload is cargo mass. This is 350, and I have front seat passenger, right? That is 300. So this is part of payload, correct? And this pilot is a part of what? It is part of dry operating mass. Operational equipment is also part of dry operating mass, and what standard empty mass or basic empty mass is also part of dry operating mass. So this is my full dry operating mass. This is my payload. This is my reserve fuel. Reserve fuel is how much? 150. So if I add all the three, I will get 350 plus 300 plus 35 plus 1764 plus 150. So this comes out to be 2599 kg. So my maximum landing weight is how much? 2599 kg. And with this, I'm done with the question number 8. Now we have arrived to question number 9. Maximum structural takeoff mass is 48,000 kg. Maximum structural landing mass and maximum zero fuel mass is given. Taxi fuel is given and contingency fuel is given. I know taxi fuel is of no use mostly. And alternative fuel is given. Final reserve fuel is given and trip fuel is given. Determine the actual takeoff mass. Actual takeoff mass means maximum takeoff mass is needed to be found out. And that means like we don't need to even find what we say payload also. So I'm given what? Maximum structural takeoff mass. So MTOM is given. MSTOM, that is nothing but 48,000 kg. Then I have maximum structural landing mass, MLW. Then I have maximum zero fuel mass, MZFW. So this is plus trip fuel. This is plus FOB. So this is nothing but 44,000. This is 36,000. So what I know, I already know the trip fuel. The trip fuel is 9,000. So this will be 9,000. This is nothing but 53,000, 53,000. This is 48,000. This is 53,000. Of course, higher value. Then this is 36,000 plus FOB. Now to find FOB, I will badly ignore taxi fuel. I will use contingency fuel, alternate fuel, reserve fuel, and trip fuel. So this will be 900 plus 1100 plus 800 plus 9,000. So this is 118. 100. So this is 11800. So this is 47800. So this is this value. This is, so I can say which one is the lowest value. Lowest of the three is MZFW. This one. So I can say maximum take off weight is nothing but 47,800 kg. This is the safest weight which one should be carrying. Okay. So this is my maximum takeoff weight. This was so easy. I don't know how this becomes a ninth question. We have arrived to question number 10. An aeroplane's weighing schedule indicates that the empty mass is 57,000. Empty mass means basic empty mass is 57,320. Normal dry operating mass DOM is given as 60,000 and maximum zero fuel mass is given as 72,100 kg. Which of the following is correct statement in relation to the aeroplane? To this aeroplane. So operational item have a mass of this and maximum useful load is this much. So first we need to find out traffic load or useful load. So first we'll find out the traffic load or useful load, or maximum operational load also we can find out. So to find out maximum operational load, what we need to do? What is my maximum operational load? That is nothing but dry operating mass minus basic empty mass. Correct? So that is nothing but operational load. Correct? So that will be nothing but dry operating mass is 60120 minus basic empty mass is 57,320. So this comes out to be 60120 minus 57,320. This comes out to be 2800 kg. So my operational item mass is 2800 kg for sure. And this was there in the options everywhere. So it is of no use finally. Then we have to find out payload or traffic load. So payload will be lowest of the three, but it is already given only one. So we will find out that one. This is maximum zero fuel mass. So maximum zero fuel mass MZFM plus FOB, right? So what is my FOB here? My FOB is how much? FOB is zero fuel mass is given and basic empty mass is given, dry operation mass is given. Oh my god, my FOB is not at all given. So how will I find out payload? Well, I can find out my payload anyway, because this is nothing but MTOW, right? This is my MTOW is equals to FOB plus DOM plus payload. Correct? So FOB plus DOM plus payload, my FOB gets cancelled. So this will be payload is equals to MZFM. MZFM is nothing but 72100 minus DOM. DOM is how much? 60120. So 72100 minus 60120. So this comes out to be 11980 kg. So this is option B. Yes, we got the 10th answer as well, and I am very satisfied because, you know, this is just filling me so much right now that we are able to solve this many questions continuously. Now let's quickly solve our 11th question as well. If the details of the aircraft from M to N are given below, no fuel is available at N. So what I know that I am going from M to N, and there is no fuel at N, correct? Distance from M to N is 750 nautical mile. Average TAS is 380. Average TAS means true air speed. If my speed is how much? 380 knots. So average TAS is 380 means my speed of the aircraft is 380, but Will my speed of the aircraft be 380? Just imagine if I'm going from this to this, and it is saying that wind component from M to N is 30 knots. HW means headwind. So that means the head, the face, the nose of the aircraft is facing 30 knot speed of the headwind. So what I can say, if the wind is flowing in this direction, I can say the speed here in this direction, speed of the aircraft will be 380 minus 30 headwind. So this will be 350 knot. Whereas in this direction, the speed will be 380 plus 30, because it will be adding by the vector formula, we can say. So this is 380 plus 30. So it will be added to the speed. So this is nothing but 410 knot. Correct? So we got both the speeds of the aircraft. From M to N, it will be 350 knots. From N to M, it will be 410 knots. Okay, I got these two values. We have reserve fuel as 500 kg. Aircraft massless fuel and traffic load is 5 to 1000 kg. That means this is my DOM. This is my DOM again. This is my DOM. And this is my fuel reserve. So this is my reserve fuel. This is my maximum takeoff mass. And this is my maximum takeoff mass at M. This is at N, maximum landing mass at N, maximum landing mass at M. So first I will find out maximum takeoff mass, MTOM, at M. Because we are starting from M, right? We have to go from M to N. So maximum takeoff mass, I will take from maximum takeoff mass at M, and maximum landing mass. Where I'm landing, when I'm taking off from M, I'm landing at N. So maximum landing mass I will take at N. So these two will be my values. I'm not given maximum zero fuel mass, so I don't care about that. Apart from this, I need trip fuel, right? Trip fuel. So trip fuel is already given. Is it given already? No, trip fuel is given, fuel reserve. I'm not given with trip fuel. So I need to find out trip fuel. First, I need to find out trip fuel. Now, trip fuel is not very easy to calculate in this case. So to calculate trip fuel first, what I will do is speed is equals to SPEED, speed is equals to distance by time. So speed here is given. Speed is average true air speed is 380 knots. And from M to N, I know from M to N, my speed is 350 knots. So 350 knot is equals to distance. Distance is how much? 750 by time. So can I get my time from M to N? Time from M to N is how much? Time from M to N is how much? 750 divided by 350. So this comes out to be 2 hour 8 minute. 2 hour 8 minute 34 seconds. Okay. So this is my time from M to N. And if I want to find time from N to M, time from N to M will be how much? It will be 750 by 380, because, 380 nahi. This will be 380 plus 30, right? So this will be 750 by 410. So this will be 750 by 410. This is equal to 750 divided by 410. This is nothing but 1 hour 49 minute 45 second. Now I am given time from M to N and time from N to M. Average fuel flow, which is 57,000 kg per hour. I will get the trip fuel, correct? Because this is kg per hour. Kg per hour multiplied by hour will be giving me kg. So that is nothing but my trip fuel, or the weight of the fuel consumed in the trip. Got it? Weight of the fuel consumed in the trip is nothing but average fuel flow multiplied by time from M to N and time from N to M. So trip M to N is equals to 2 hour 8 minute 34 second multiplied by 57,000. Oh, sorry, 5,700, not 57,000. So this will be equal to 1213.8 kg. And trip N to M will be how much? Trip N to M will be 1 hour 49 minute 45 second multiplied by 57,000, or sorry, 5,700. So this will be how much? This will be 1 hour 49 minute 45 second multiplied by 5700. So this comes out to be 10426 kg. 10426 kg. So this is trip M to N and this is trip N to M. Now I got trip M to N and trip N to M. What will be the reserve fuel from M to N? Or what will be the fuel on board? FOB M to N will be how much? FOB will be trip fuel M to N. This will be this one 12213.8 plus any other thing is there, then trip fuel plus reserve fuel, right? Reserve fuel is how much? Reserve fuel is 500 kg, so it will be reserve fuel. Will this be my FOB from M to N? Correct? No, this is not correct. Why? Because we have to add trip from N to N also, N to M also. Why from N to M also we have to add trip fuel? This will be 10426 also. We have to add this. Why we have to add this? Can anyone tell me? Think. Because in the question it is written, no fuel is available at N. That means if no fuel is available at N, for the trip from N to M, from Nagpur to Maharashtra, from Nagpur to Mumbai, just imagine this is Mumbai, this is Nagpur. So from Nagpur to Mumbai, if you want to go, then again you have to use, like you need fuel, right? But at N, at Nagpur, there is no fueling happening. So what we can say is, we have to carry that fuel from the station M. From the station M, when you are going to N, we have to carry both the sides trip fuel, correct? So we will add trip fuel MN plus trip fuel NM for the reserve fuel. So this will be FOB from M to M will be 1221.38, 12213.8 plus 500 plus 10426.25. So this will be plus 12213.8 plus 500. So this comes out to be 23139.75 kg. So this is my FOB N M to N, and FOB N to M will be how much? N to M will be, this one will be consumed, right? This trip fuel will be consumed till then. Trip fuel will be consumed. This will be done, right? So I will have only this one from N to M when I'm going from N to M, this direction to this direction. So what I will be having, this will be 500, which will be reserved, plus 10426. So this is nothing but 10926 kg. Correct? This will be 10926 kg. Now I have everything in my pocket. So first I will find out maximum traffic load from M to N and then maximum traffic load from N to M. So first I will do the maximum takeoff weight at M. Maximum takeoff weight at M is 91,000. So 91,000 kg. Maximum landing weight at M will be how much? Maximum landing weight at N is how much? 77,500 kg. Plus trip fuel. Trip fuel will be how much? Trip fuel will be 1221.3. Correct? This will be my trip fuel. Will I add trip fuel from N to M as well? No, trip fuel from M to N should only be having trip fuel from M N. That means Mumbai to Nagpur. Only that trip fuel will be added. We will not do any other addition. So this will be what? How much? This will be 3.8. This will be 1. This is 7. This is 8, 9. This is 8. This is this one. So we can see that this is lesser than this one. So we can use this one as my maximum takeoff weight. So maximum takeoff load is maximum traffic load will be how much? Maximum traffic load is nothing but 89713.8 minus FOB minus fuel on board is how much? 23139.7 minus this is MTOW minus FOB minus DOM. DOM is how much? Dry operating mass is this one. 52,000. So this is 52,000. So my value comes out to be 89713.8 minus 23139.7 minus 52,000. This comes out to be 14574.05 kg. So this is around how much? This is like exactly all three. So we got all the three correct. So this is my first answer is correct for sure because it is near to the value which is there. So either A is correct or either C is correct. Okay, 14573 or so 14503 is incorrect. So now I need to find out the second maximum takeoff maximum tax. Now I need to find out maximum traffic load at N to M. So this is M to N. This is maximum traffic load at N to M will be how much? Again, we have to find out maximum takeoff mass and maximum landing mass. Again, we have to do the same calculation. So to have the same window, again, I will write everything. MTOM at N, MTOM LW at M. So this will be equal to 88,000, and this is MLW at M, that is equal to 75,000. So 75,000. Now this plus trip fuel will be trip fuel is 10426 10426 62458. So this is 85426. So this is the lowest one. So I can say maximum traffic load N to M will be 85426 minus FOB minus DOM. So minus DOM is 52,000 minus FOB N to M is this one. So minus 10926. So this comes out to be, this is 52,000. So this will be equal to, this is 52,000. So this is 0. One more 0. So this will be 22,500 kg. This should match somewhere. So this is my answer. This is my answer. Now let's do the last question, which is question number 12. Now let's solve the 12th question. An aircraft is to fly from A to B. Maximum takeoff mass structure, this is MTOM, is 82,000. Maximum mass without fuel and traffic is dry operating mass, correct? Without fuel and without traffic load, this is dry operating mass. This is fuel requirement is given in PLLM as MLM. Maximum landing mass is given as 64,000. Then we have fuel requirement. This is for flight A to B. For flight A to B, this is trip fuel. And reserve fuel is this. This is 8,000. If the aircraft land at B having consumed 500 lb of reserve fuel, okay, this time the reserve fuel is also consumed in the trip fuel. 500 lb of reserve fuel, what is the maximum traffic load that can be carried? So what I know that my trip fuel is how much? 16,000 plus 500, correct? My trip fuel is how much? 16,000 plus 500, and my fuel on board is how much? That is 16,000, which is trip fuel plus reserve fuel, that is 8,000. That is nothing but this is 16500. This is 24,000 kg. Got it? Now what I will do, I will make again the table. First I will put this above. So first I will put like this. I will put it here somewhere where you can see also, and where this will not disturb me. So first again I will make the table. This is my MTOM. This is my MLM. My MTOM is how much? 82,000. MLM is how much plus trip fuel? My trip fuel is how much? This is 16500. So MLM is 64,000 plus 16500. 5009, sorry, 10. This is my MLM and this is my MTOM. Now, my traffic load, maximum traffic load will be how much? MTOW2 minus FOB minus DOM, correct? So that is nothing but 80500 minus FOB is 2400000 minus DOM. DOM is how much? 50,000. 50,000. That is nothing but 80500 minus 24000 minus 50000. This is 6,500 kg. So my answer C is correct. And all the questions are done with this. So you know how maximum takeoff load or traffic load is calculated. And with this, I'm done with this chapter. Fully done. You are done with this chapter. And if you still have any doubt, you can message us, WhatsApp us, Telegram us. You can directly call us. You have so many options, but you're not doing it right now. Please do it, right? So join us for one-on-one. One-on-one means I will teach you one-on-one live. That will be so good. No teacher provide this. And why should take us instead of any very highly qualified fighter pilots and so many of things? Because they are good with driving, but they are not good with ground classes. I bet you that anyone who has taken the classes, you can ask them, and you will get the same answer as what I am saying, because we have already the students from the very highly qualified teachers who are coming to us. So you can just think of why they are coming to us. Because we are highly affordable. First of all variety of question coverage is done by us. All the types of question is done by us. All the type of question which will be there in the exams, we assure you that we will solve all the type of question. Then we have syllabus coverage guarantee. That means we guarantee that we will cover the syllabus which is there according to the DGCA. We will cover full DGCA syllabus, right? And then career counseling, no one gives you that because nobody cares about you other than us. So we will give you career counseling. We'll tell you whether you should go to Canada, USA, whether you should be in India. We'll talk about different flight school in India, different flight school in South Africa, Russia, not Russia, but what we say, that region is there, na? Okay, some region in Europe. We know about that also. I just need to find out right now. Then other than that is one-on-one teaching is the limited offer, because we have less people right now. But if we have more people, then we cannot assure you one-on-one teaching, though this will be constant. But one-on-one teaching will be reduced. If you want that one-on-one experience right now, join and get your air navigation done with flying colors. I assure you that in the first attempt itself. Okay, so take a free demo to validate and enroll. So if you're thinking that I'm lying or something, you can validate us, you can ask us, you can cross question us, and then enroll to our classes. So have a demo class with us and then pay in installments, not in the first go itself. Okay, so you can pay in that way as well. So you can pay us if you find it helpful, of course, because we would be very happy to have it, because of course this is free material online. And please like, right? Because we are very likable people. And then also share with your friends. Anyone who is facing doubt in Payload, 5% of the course comes from Payload. 5% of the topic of air navigation is Payload. So this is very important to share with your friends, lovely friends, because this is not a competition exam, right? And subscribe, why not? And then hit like that, hit the bell icon, and then comment your doubts, because I will reply all the doubts you have. Okay, so with this, I sign off. Bye, pilots.